UK Wine Show, show number 865. Dr. Darrell Lizamore on breeding new clones of Sauvignon Blanc. Hi, my name's Chris Scott.
And I'm Jane Scott.
And together we founded 3050 and the UK Wine Show. On this week's show, I'm sitting down with Dr. Darrell Lizamore from Bragato Research Institute in New Zealand, who is leading the hunt for new clones of Sauvignon Blanc. New Zealand is a country where getting new plant material into New Zealand is very expensive and very slow. So we find out how you can work to improve the diversity of Sauvignon Blanc to identify clones that have traits that we like. We get into how the team deliberately stresses grapevine cells to force mutations and is well on the way to planting a vineyard with 10,000 different Sauvignon Blanc clones. Well, I hope your week is good. This week has been a pretty steady week. I've been working a bit on the website. I've been working on some new spirits flashcards, and we're getting ready for our big summer break. We're going away to the Lake District for a couple of weeks, and this will be the last show going out this week.
Yeah, and before we go on our summer break, we'd like to say a big thank you to our patrons who've supported the show this year and are helping us keep it ad-free. Just a reminder, on Patreon we share the weekly news in advance, plus you get the flashcards, daily quizzes and tasting guides to help you keep learning. It's easy to join and there's a free 7-day trial so you can find out if you want to become a member. Just head over to patreon.com/UK Wine Show.
And this week the Patreon flashcard question is all about Spanish aging categories, Jane. So what is this week's Patreon flashcard question?
The question is, what are Spain's 4 age categories from youngest to oldest?
Okay, we'll see how you get on with that at the end of the show. But next up, we've got the news.
Well, first up this week, France's relentless summer heat and prolonged drought is leaving its mark on the 2026 vintage, with devastating wildfires sweeping southern vineyards as growers begin the earliest grape harvest ever recorded. Heat and drought are forcing harvests weeks ahead of normal, while raising fresh concerns over crop losses and wine quality. More than 11,000 hectares have burned in southern France, prompting mass evacuations and a red fire alert across several departments. Vineyards in Menevois and Roussillon have suffered fire damage, while producers fear smoke taint could affect grape quality, echoing problems seen after previous wildfires. At the same time, growers have begun harvesting grapes earlier than ever before. The first fruit was picked in Fitou on the 15th of July, and many regions expect harvests 1 to 2 weeks ahead of last year's early harvest. While winter rains initially promised a generous crop, continued heat and drought are shrinking berries and stressing vines and threatening yields, all highlighting how increasingly extreme summers are impacting French wine production.
Drought and smoke taint are big problems for vineyards, even if they miss the actual burning. At least now there are tools to detect smoke taint in juice and wine, and even new clever filtering techniques to remove it from some wines. Smoke taint has moved on a lot in the last 10 years, mainly associated with a lot of the wildfires in California and Australia. The new hot technology, if you like, is called molecular imprinted polymers. And these polymers are created with tiny cavities shaped specifically to capture the target molecule, almost like a molecular lock and key. They've been designed to preferentially bind smoke taint compounds while leaving more desirable wine aromas behind. That's the big problem with smoke taint. You either strip out half the wine to get rid of the smoke taint, or you have wines that taste like ashtray. Some of these molecular imprinted polymers get to remove just the things they want. What's the next story, Jane?
Well, Ian Harris MBE has been installed as the 531st Master of the Worshipful Company of Vintners, bringing nearly 5 decades of wine industry experience to one of the trade's oldest and most respected institutions. Harris will spend the coming year representing the Vintners Company while supporting its work in the wine trade, education, charitable giving and fellowship. Best known as Chief Exec of the Wine and Spirit Education Trust from 2002 to 2022, he oversaw the organisation's remarkable international expansion. The appointment has particular significance given the Vintners Company helped establish the WSET in 1969 and remains a long-standing supporter of wine education. Harris, who received an MBE in 2008 for services to the wine and spirits industries, said it was a tremendous honour to serve as master and is looking forward to the year's industry events. He succeeds Richard Wilson, MBE.
The Vintners Company was founded in 1363 with a royal charter, and the company continues to support education and scholarship, as Jane said. So a big congratulations to Ian. We had him on the show last year talking about the Vintners Company when he was being groomed for the job. Now it's official. What's the last story, Jane?
Finally this week, England's wine industry celebrated a record harvest in 2025, but faces growing commercial challenges as a surge in production leaves many wineries battling excess stock and downward pressure on prices. English wine production climbed by 55% in 2025 to 124,377 hectolitres, equivalent to more than 16.5 million bottles. That followed a warm, dry, growing season that delivered high yields and excellent fruit quality. White wine output more than doubled, while favourable weather boosted ripeness across key varieties, including Bacchus, Solaris and Pinot Noir. The sector continues to expand, with more vineyards, increasing investment and exports rising by 35%. Still wines are also becoming a larger part of production, as regions such as Essex build a reputation beyond sparkling wine. However, the bumper crop has intensified an existing supply glut after stocks from previous vintages remained unsold. Larger producers have relied on heavy discounting, squeezing margins for smaller wineries. While wine tourism and exports are providing some relief, the industry must grow demand at home and overseas if it's to maintain profitability without sacrificing value.
I saw an interesting article this week which said that the 25 top producers in the UK account for 84% of all wine sales in the UK. So it is concentrated at the top, that's for sure. And there is definitely an oversupply at the moment. But the thing about UK vineyards is that every now and then you get an almost total crop loss, switching from a massive surplus to a deficit. This year, we had 2 early frost events and meant quite a few vineyards in southern England not only lost the buds, but they also lost their secondary buds. Some plants will produce tertiary buds, but the yields will be tiny. Add some drought stress this year and the crop is not going to be huge, but will it be small enough to take the pressure off? We'll find out in the next few months. Okay, Jane, let's get a reminder of this week's Patreon flashcard question.
The question is, what are Spain's 4 age categories, from youngest to oldest?
We'll give you the answer to this week's flashcard after this week's interview, which is coming up with Dr. Darrell Lizamore. Darrell is a plant geneticist based in Lincoln University in New Zealand and leads the Sauvignon Blanc Clonal Diversity Program at the Bragato Institute. After his PhD in grapevine genetics, he has spent years building a national collection of new clones to solve problems for the country's wine industry. Let's have a listen to what Darrell has to say. Hi, my name's Chris Scott and I'm here with Dr. Darrell Lizamore. How are you, Dr. Darrell?
I'm great, thanks, Chris.
What do I call you, Dr. Darrell?
Just Darrell's.
Darrell's.
Yeah, please.
Nice. Last week we were talking about all the different ways you can fiddle around with the genetics and the traits in a grape variety and play with them and see what you can do and try and get new things that might be useful. This week I want to look at some of the work that you're actually doing here in Lincoln. We're here in Lincoln, just outside of Christchurch, and you've got a brand new sequencer, a British sequencer.
That's right, from Oxford Nanopore Technologies.
What's it called?
It's called the Promethean.
Promethean, isn't that a Greek boat or something?
Big monster or something, I guess.
Yeah. I think it was something from Aliens. Wasn't there something from
Aliens? That's right, there's an Aliens movie along the lines of Prometheus, that's what it was.
Yeah, that's right. But what we're going to talk about today is the work you guys are doing in terms of trying to develop clones of Sauvignon Blanc that might have traits that you're looking for. So before we get into that, do you want to just give us a bit of a history about what it is and where it's at?
Sure. So This program is fairly young. In fact, all grapevine improvement in New Zealand is fairly young, just like our industry is. And the industry has frequently identified that one of its major risks is a lack of genetic diversity. We don't have any native grapevines. All we have is the vines that were imported and have been planted here. And that set of diversity has, in some cases, been lost. Only a certain subset of the world's global genetic diversity in grapevines, a tiny subset, was brought here. Some of it has been lost over time, and it's very hard to bring in new material because of our biosecurity requirements. And so this project was aimed at tackling part of that challenge of new genetic diversity. Without diversity, there's no option for improvement. There's nothing to select from. It's specifically focused at new genetic diversity that is still Sauvignon Blanc, because 85% of what we sell is Sauvignon Blanc. It's such a premium market signal. A lot of our industry's interest has been, how do we produce something that addresses some of our priority traits, like higher productivity, new flavors and aromas, resilience to disease, but is still Sauvignon Blanc, and hence clonal selection.
Yeah, and also with climate change, things like, I think you mentioned last week, things like bud burst might become quite important.
Absolutely.
And issues like that as well. So there is some traits that you might want to improve on for the New Zealand situation.
That's right.
But there's also traits you don't want to lose, like that vibrancy of flavour and the acidity and all that type of thing as well. So how long has the project been running, and when did it start?
So the project has developed out of work that started in 2009 at Lincoln University to understand what causes clonal diversity and can we change the rate at which these natural changes happen. That was when I was doing a PhD in Dr. Chris Weinfield's group. After that, we started to partner with Plant and Food Research, who are also here in Lincoln, and did a proof of concept, first in Chardonnay and then in Pinot Noir, to show that we could produce new clones of diversity. And then when New Zealand wine growers set up the Bragato Research Institute, I joined them, and the goal was to try and produce a useful level of diversity in Sauvignon Blanc, our premium varietal that we grow. And so since 2021, really, the program has been aimed at producing new clonal diversity in Sauvignon Blanc. It runs till April 2030, and it's aimed at producing first the subset of diversity so that we have a collection, and then at starting to identify useful improvements in some of the priority traits within that collection.
Okay. What's the method you're using to do this?
Yeah, so technically it is mutagenesis. We do it from individual cells called somatic embryos. So they are embryos, cells that can grow into whole new plants, but they're somatic because they come from vegetative tissue. They're not from the seed. That we don't use pollen or anything like that. We basically take a process called tissue culture, which is where you are propagating a small amount of the plant in a sterile environment. The sterility is just to keep it going and provide all the nutrients it needs. And then you rejuvenate whole plants from that.
So you take a bit of plant material, extract a subset of that can then grow into a new plant, and then you twist it up a little bit.
The first bit, getting some cells that are rapidly dividing but are not whole plants. They're basically stem cells. These are, the technical term is totipotent. It means they can become any new type of tissue, and by plants determine which type of tissue they grow through their hormones. And so if you apply a certain type of hormone, plants start to grow leaves. If you apply another hormone, they grow roots. But if you apply a balanced combination of both, they do neither. They don't differentiate, they just multiply their cells and they maintain this tissue that can become anything. So that's the first step, is producing this stuff. And it's similar to how you do virus elimination. You grow a small amount of tissue and then you recover whole plants from that. But if you can do that, it gives you the opportunity to expose those cells to a stress event which causes random mutations, and then recover whole plants that have any of those genetic changes in every cell of their being. So what we want is to produce thousands and thousands of plants, but each of those plants has a genetic change and it's different to the plant to its neighbor.
So that gives you your variety. What's the stress that you apply?
So that was one of the really big scientific questions of what causes differences, and people thought maybe it's high UV because anecdotally we see higher rates of mutation in New Zealand and we have quite high UV here. We tried temperature shocks and all kinds of things. One of the things we found had the biggest impact was growing grapevine cells in the presence of extracts from yeast from vineyards.
Oh, really?
So the interaction between microorganisms and grapevines seems to change the rate at which their DNA adapts. We don't actually use microorganism extracts anymore because it's very hard to control the dosage, and the microorganisms, if they're not completely removed, they kind of overgrow the grape cells. Hard to get sterile grapevines back from that. But through that, we learned that it's the epigenetics of the DNA that is changing, and so we now use chemicals that mimic that same effect that those microorganisms were having.
Okay, but if you're just changing epigenetics, we spoke last week that they could just change back. Don't you want to change?
That's a really good question. Yeah. So initially, the epigenetics itself is not how we're recovering the diversity, but plants have parts of their DNA that can cause genetic change called transposons, regions of the DNA that can move around. Colloquially, they've been called jumping genes, parts that can be expressed, reinsert, and cause a mutation. Because they cause these mutations, and most mutations are deleterious, they're generally silenced, highly silenced by methylation. If you remove that methylation, then they can become more active and produce more of the spontaneous genetic diversity.
Well, I don't pretend to understand exactly what methylation means. What I think you're saying is that when you expose it, the DNA sequences just get jumbled up, and normally that's bad, so it doesn't express itself, but you're saying that somehow you're getting it to express itself and stay expressed.
That's right. Actually, we don't even need it to stay expressed. Normally, the plant stops that from happening because if they had too many mutations, their traits wouldn't be stable. But we just need to give them sort of a few days, 48 hours, for example, of a period during which their systems which stop them from becoming more genetically diverse are turned off. The interesting thing is even tissue culture itself is a genetic shock. It causes a stress to the DNA. We don't know if that's because of the fast rate of replication or because of the fact that stem cells or these totipotent cells need to have a very low degree of epigenetic methylation because all genes need to be able to be switched on. But just taking them through tissue culture actually causes a higher rate of genetic mutation than growing plants from cuttings, for example.
Okay, so you've now got these stem cells, or what do you call them?
Totipotent, their potency is total. They can become anything.
Yeah, totipotent. Sounds like a tutti frutti ice cream. I've got myself some totipotents, and I'm going to have that with my sour sweets. Okay. So you've got how many of these have you created?
So we've now made 10,000 vines of Sauvignon Blanc together with our partners BSI here in Lincoln. We sort of developed the process and then they scaled it up for us. They figured out how to apply it to making tens of thousands of plants. And we have a new breeding vineyard we've now planted 9,000 of those plants. They go in as tiny little seedlings. We have to recover plants through tissue culture on an agar, on a nutrient medium. They then have to very carefully be deflossed, which is a process of taking them out of the sterile environment through the nursery. Yeah. It's called hardening off. It's basically toughening them up to be able to withstand an external environment. And then when they are strong enough, we can plant them out in the breeding vineyard.
How many of the cultures, the stem cells, have had their DNA jumbled around so much that they just fail? They're not a viable plant.
Yeah, it's a great question. And it's hard to say because they're being jumbled about when they're just blobs of cells. If they're so badly damaged that they can't become a new plant, they probably never grow. So they're kind of removed from the population before we ever recover them. We do at every subsequent stage find unusually weak ones that will never survive. We generally try to baby them along a bit because we don't know if that's just maybe there's a very valuable one that is particularly vulnerable at an early stage. But you're right, there'll be changes that mean that plants never grow back from that cell because of the way that its DNA changed.
And how much change in the DNA is there? Is it still technically a Sauvignon Blanc, a clone of a Sauvignon Blanc?
Yes, so what's happened is that the genetics has changed in the exact same way that happens out in a normal vineyard. So of those 10,000, we've done whole genome sequencing of 100 of them so far. They're all genetically unique. That means that they all have changes, but the number of DNA changes, and we've done whole genome sequencing on about 20 commercial clones of Sauvignon Blanc, it's in the same ballpark, about the same number of DNA changes in our clones as there are in the commercial ones. They're the same type of DNA changes. They've basically just gone through something that naturally happens at a very slow rate, but just in one generation.
So you're sitting here now with, what, haven't you say 9,000 plants out in a test vineyard, growing away. How big are the plants? Are they?
So they've come out over the last 3 years. The most mature plants they're over head height. They produced flowers this year, and the smallest ones were planted last week, and they're sort of less than a foot in height and maybe 3 millimeter trunk diameters. They go out at a very juvenile stage, very immature.
Okay. And what's the idea? Because normally when you're doing a clonal selection and you're not using genetics, you would let them grow, and then if you're, say, looking for mold resistance, you'll just leave them alone and see which ones get covered in mold and which ones don't. But I imagine you're doing it a little bit fancier than that, are you? Or?
True, and that's the problem of that type of thing would be a destructive assay. You could do that for mold or frost or anything. You could say, let's let 99.9% of them die and see what survives, but then you can only check one trait because you've eliminated most of your population. And so we're quite conservative in our spray program. We make sure we're applying spray, and then we have to come up with specific assays that can test in quite a high confidence way whether this one plant is more resilient to mildew than another, without actually letting mildew into our vineyard, and also in a way that's cheap enough to do on 10,000 vines in one season at approximately the same time of year, because otherwise you start introducing too much environmental and biological variation.
So how do you do that?
So for each trait that our industry has prioritized, we've looked at different tests that we can develop. In the case of powdery mildew resistance, I thought this was going to be something we'd only be able to do much later once we could replicate the trials. But in fact, there was a device developed by the US Department of Agriculture and Cornell that they dubbed the Blackbird. But basically it's a set of optics, it's a microscope on a 3D control platform. And so what we do, we punch a leaf disc from each of the vines.
So you just get a little round disc of leaf.
That's right, about 1 centimeter in diameter. And on these leaf discs, we put them on a tray and we spray them with an inoculum of powdery mildew spores. So a set dosage of powdery mildew spores evenly applied over hundreds and hundreds of leaf discs. And then we grow them for about 10 days. And we use this robot to take photos of each leaf disc. And it takes about a dozen photos of each leaf disc at different heights, combines them into a single image and per leaf disc, and then uses a machine learning, an AI algorithm, to give them a digital score for how much powdery mildew grew on each leaf disc.
Okay. And what sort of variation are you seeing?
We do see quite a bit of variation in the collection so far. I'm hesitant to draw any conclusions until we've really done enough replicative trials that we know that plant X consistently shows less susceptibility, but it's a good amount for us. It's really quite promising and gives us a subset of the population to focus on, and that's the key for us right now.
Okay, and is it just molds and mildews you're worried about? As we get warmer, we're going to get bud burst earlier, and you're going to get more frost events and things like that, possibly. It's one of the risks in the UK anyway.
That's right.
So are you looking
more extreme weather events as well, so more likely to have these seasonal frosts.
Are you looking at things like bud burst, veraison, any of those other characteristics?
Absolutely, yeah. So some of the traits that are related to phenology, like timing of bud burst, is a big one for us, because if you can even just push that back a week or two, you reduce your exposure to those spring frosts. We've got a very interesting approach that's being tested that we've done in collaboration with the University of Washington and the University of Canterbury near to us, that looks at the temperature at which the tissue freezes, so differences within the population of sort of susceptibility to freezing. That's another way of getting frost resilience. And then when you talk about ripening, a big challenge for our industry is in a warming environment, you get sugar ripening coming on earlier that makes higher alcohol wines, because you have to let the fruit hang to develop these flavor compounds and acids. And so for us, looking at the variation between sugar and acid ripening, and looking for plants in the collection that that don't have quite as quick sugar accumulation. So you could select for clones that maintain that cool climate style in a warming environment.
And are you still creating more clones at the moment, or have you finished that and now you're in the analysis phase?
Yeah, we've just finished, as of a few weeks ago, we've now finished producing the total number of plants and have planted them out.
You're looking at the traits of the plant, but not necessarily how the final wine tastes.
That's right.
What's the process? Are you doing, because it's no good having a wine that's completely mold resistant, great for frost, but it tastes like rubbish.
Exactly, yeah. Quality is always primary for our industry. So one of the advantages of clonal diversity is when one thing changes, it doesn't necessarily impact everything else. If we were breeding, because you're shuffling the genetics at every generation, you get what you want, but you also introduce a whole lot of other changes. The advantage of clonal selection is that most other stuff stays the same. However, you do need to validate that. So we do DNA sequencing so we can actually understand what has changed in the genetics of this plant. And then we've done some trials where we've taken a large collection of the plants. Usually we pull them for wine assessments. At this stage, it's just because we want to validate that the plants we're recovering...
You just want a couple of glasses of wine, mate.
Our research wines are nothing to write home about. But mostly what we just want to know is this still Sauvignon Blanc? Are we sure that on average, although each individual might have a tweak here and there, the thing they have in common is that they're still like the parental clone that we started with, and we've managed to validate that. But you're right, we do need to get to, wow, this plant is promising, what is the quality of the wine like? So we have another project, BSI, or Plant Food Research, that is looking at single vine winemaking. Can we make small ferments and look at the chemistry of those ferments, the volatiles in the headspace, and actually assess them even when we only have a single vine?
The next step is obviously if you find a group of plants that have really good disease resistance, will you do genetic testing on that to try and identify the genes that have induced that?
That's the plan. And a big part of that is because we only know the function of a minority of the genes that are in grapevine. The strength of this approach is that we are producing changes that will create traits that we couldn't have made intentionally because we wouldn't have known what to do. But the weakness is it's random. We just have to make a whole lot of changes, which means there's a big cost in plant production and screening these plants. But the advantage of knowing what changed, if we have a change in gene X, which creates a trait improvement that we want, we could, if we wanted to replicate that in Pinot Noir, for example, we could just screen the plants for that trait. And we could use a very cheap genetic technology like PCR to pick the plants of interest. It also allows us, because we collaborate with other international groups, like we just had Kai Vos-Fels, who leads a breeding program in Geisenheim. They have thousands of Riesling clones. They're also sequencing theirs. So we have these comparative databases where he can say, I've found this interesting trait and this was the change, and I can look in my database and say, do I have a plant that has the same change? It's far cheaper and quicker to import that kind of knowledge than it is to actually ever import the plant material.
We talked last week about cis genetics, where you're taking a gene from another Vitis vinifera, like maybe that Riesling plant from Geisenheim.
Yep.
Would you consider going, okay, we've got this Pinot Noir, it's got really good traits, but it's missing that one trait. Would you consider cis genetics or to do it, or is that a little bit, it's a little bit dodgy?
As a research tool, I think it's a fantastic idea. Even as an application, it's brilliant because it's been validated. It's a really viable approach. The big question is, would anybody want it? In New Zealand, under our current laws, that would still be considered GMO. So I could only do it in a quarantine lab. It could never come out of the lab. And the next question is really, if you had taken some DNA from another variety, would you still be allowed to call that Sauvignon Blanc? And that's kind of an open question at the moment.
Yeah, okay. At the end of the project in 2030, what do you hope to have, and what's the next steps after that?
Our goal at the end of this project is to have two things. One is the collection of diversity, effectively a repository of genetics for the industry that is a lasting resource, and that has been something that the industry has never had before, specifically in our premium grape variety. But also we aim to have plants that have been identified because they have improvements in the traits that our industry has prioritized, and we want to have validated those on commercial vineyard. At the moment, taking top grafting buds of the vines in our breeding vineyard onto rootstock in Marlborough, established rootstock in Marlborough, and that seems to be working quite well. But I think within the scope of this program, it's going to be, can we show that we have plants that have improvements, those improvements are validated in Marlborough, but there will still be multiple seasons needed on multiple sites on commercial scale blocks with winemaking before anyone's going to have the confidence to order a set of cuttings for the next vineyard of that.
Yeah, exactly. And it was to nurseries, really, isn't it? They're the ones who...
Exactly, yeah. So we have nurseries who are grantors on the program, who are part of the program and who are doing those grafting trials for us. And you're right, they're the next user in the program.
All right, then. I think we'll wrap it up there, Darrell. Thank you very much.
Thank you very much.
Okay, that ends our interview and almost the show this week. There's two things about this clone work that he's doing that is quite interesting. First of all, as he said, it gives variations that can help viticulture, but it also gives scientists a brilliant sample size to do experiments to identify exactly what different parts of the DNA do. By having effectively clones with one minor change, if they see changes in the plant, they can then trace that back to that physical genetic change. Rightio, Jane, let's get the answer to this week's Patreon flashcard question. And the question was, what are Spain's 4 age categories from youngest to oldest?
Okay, well, the youngest I know is Joven.
Yep, Joven or Joven, yep.
Yep. And then we've got Crianza, then Reserva, then Gran Reserva.
Looks like you're pretty confident on that.
That's right, but do you want to give the ages for those 4?
No, I don't. And the reason I don't is because it varies. Different regions have different age restrictions. There's a national published age range, but then Rioja and Priorat do their own thing on those as well.
Okay. And I've just dug out the national numbers, actually. And Joven, so this is minimum total aging. And remember, there's a difference between time spent in barrel and bottle, but the minimum total aging in months, for Joven it's 0. For Criantha it's 24 months.
2 years.
For Reserva it's 36 months.
3 years.
And then Gran Reserva is 60 months.
5 years. So
Yep.
0, 2, 3, 5.
And that was for red wines that we just read out.
But they also have minimum agings for white wines and it by region. It's actually a lot more complicated than you think.
Well, thanks, Chris, and thank you for listening. And if you enjoyed the episode, don't forget to subscribe wherever you get your podcasts. And a little reminder about the Patreon community. If you'd like to join us and support the show, head over to patreon.com/UK Wine Show.
And don't forget, this is our last show for our summer break. We will be back early in September. Until next month, cheers and good drinking.
The UK Wine Show is a weekly podcast brought to you by 3050, the wine tasting company. The show is produced by Chris Scott and the news is read by Jane Scott. To listen to other shows, visit ukwineshow.co.uk. Thank you for listening.